Next team is mini grid systems.
Yes. Okay, so here's we have the mini grids, but this microgrid and the mini grid, and we're connecting back to the utility. So the system design team, the mini grid system design team, they need to own the overall specification of what this, how do the pieces go together to deliver the outcome we want. Okay, and it's this not a technical thing; it's a cost and technical specification really that gets developed. So let me give you this example. Okay, if you if you're on the battery team, you have a battery voltage, right? The PV team has to have an output voltage for the PV array, and the microgrid controller team, the mini grid controller team, has to have a way to take the voltage that's supplied by the PV array, manage it so you can charge the battery, right? That's a pretty simple problem. But it takes all three groups working together to figure out what that is. And the system group is the group that actually oversees the integration of all these different parts to make sure at the end that they actually work together. Because it's possible for the battery team to go off and do something, the PV team to go off and do something, the microgrid team to go off and do something. You put them all together and they don't work, or they don't work correctly, or they don't work reliably, or they only work if you have the most expensive PV supply possible. So this team is pretty important, right? Because they have to ensure that what we supply in the end meets this price and the cost objectives and the performance objectives.
So the last team is the LED lighting and design team, which has the most progress so far out of the different teams. So talk about Jen a little bit, and then what other skill sets you need and what the team's going to do.
Yeah. So this is sort of a key part of Light the World, right? We need this LED lighting solution. It's a DC lighting solution. It's not the kind of light that you actually plug into your electric outlet in your house because that's AC. We need a DC solution because the DC solution actually is much more cost effective. It's higher efficiency. And it's sort of the cornerstone of how you think about Light the World. We're trying to bring lighting to people who don't have it. So Jen has graciously volunteered. She's a mechanical engineer. She's graciously volunteered to lead the team to get that done. But if you think about how you have to design the light, right, it's not just one skill. You need a lot of different skills. So you need somebody who understands LEDs and the temperature at which they emit the light. So do you want a yellow light or a white light? So, and how do you design those LEDs into some kind of board fixture that will meet the need that we have? You need mechanical design people. How do you mount whatever they come up with into a fixture? How do you design the fixture? How does the fixture look, right? So you need mechanical design people. You need artistic people. You need manufacturing engineers to know that spun aluminum coated in this kind of material might give us the best aesthetics at the lowest cost, for instance. So you need those kind of people. You need people who understand wiring because we need to select a cord. You need people who actually understand to pick the switches because in some way you got to turn the light on and off, right? So you need a phenomenal number of people actually to contribute, even if they just contribute an hour, into this overall effort so we get a light in a fixture with a cord and a switch that all work together that can be hung by the customer and we can have produced at a low cost. So it really does take a team effort to make something as might appear to be as simple as a light, but it's not easy. It's not simple.
So this sounds like a lot of engineers and design work. What if somebody wants to help out and lend some time in? What else could Light the World use in terms of hours put in from various.
Oh yeah, so it's a great question because so far we've spoken mainly about designing things, right? We didn't. We need some other kinds of design help. We need software engineers, right? Because our microcontrollers work on software. But in addition to that, those technical people, we also need other kinds of help. So, for instance, we're writing proposals for grants, right? We need the help of people who are familiar with the grant writing process to help us package our grant applications in the way that gives us the highest probability of getting funded. We need people to help on communications, right? Because this is an organization that we would like to have funding from a broad group of people from around the world. So we need people to help us communicate the message. We like to do Kickstarter, for instance, but that's one avenue. So we could use all kinds of help around how do we communicate the message, where do we take the message, how do we get more people involved in Light the World, both from an actual time commitment support, but also from a financial support. We need artists, actually, right? I don't want to supply from Light the World things into these countries that work but aren't aesthetically pleasing. One of the things I did learn at GE is that actually it's often less costly to make the thing look really nice. Okay, so I'd like to carry over that experience into Light the World so that when we supply something, I'd like to have an ooh and an ah from the people who get this, not just when the light's turned on, but also from the aesthetics part. And I know we can do it because I saw us do it inside of General Electric time and time again, where you get not just the right engineering outcome, the right cost point, but also a pleasing aesthetic.